This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of the Industrial AI Podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieberg. Good morning, Robert. Back from SPS exhibition in Nuremberg last week.
Yeah, back from SPS.
How was it?
It was very interesting. AI was a topic, but the focus is still on hardware.
Oh, really? Okay.
Yeah, but especially automation companies such as Beckhoff, Phoenix, Keba, Bosch, Siemens, they are, from my point of view, are fully committed to AI. But for example, when you talk about drives, right? So it remains a secondary topic for them because they want to sell their drives at the end. But I think the key thing, and this was an eye-opener for me, we have been saying that for years, AI on the edge, PLC level.
There you go. I was waiting for the word.
Industrial PC. And they accept to train the model in the cloud, but then to run it in the cloud or to share data or to use inference, to have the cloud in the back is no option for them. It's no option. And this is also...
Yeah, I mean, inference in an industrial environment never has been an option, right? I mean...
Yeah,
I think I said it before. It must have been more than 10 years ago. I think it's really 15 years ago. And there were guys from University of Stuttgart, and they were showing this wonderful theoretical setup. Must have been, were they the times of 3G, probably, I guess. And that's perfectly good and wonderful. It was very, very interesting. And they started the discussion then. And they were showing this setup of doing something in the cloud before, even before we were doing the Industrial AI podcast, right? And of course, at that time, it was already very clear, if you need deterministic communication, like I said it before, tonight again, I'm going to go to my, not the choir, I'm playing my baritone. So there's a guy standing in front, and when he holds his hand up and down, that is like the deterministic. Now, he does it every second probably, and in industrial, we do it in milliseconds. And before the millisecond, each element in the complete environment needs to be ready. And if there's one single glitch in the communication, and that happens, and that's for that reason, our voices are being recorded locally, right? So you sit wherever you sit, I sit wherever I sit, and we talk to each other, but the voices are being recorded locally, and then at the same time they're being uploaded. So long story short, I had it on here, and I was expecting it, yeah. And for that reason, you get as close as you can to where things happening on the shop floor, right?
But an edge could also be a server room, right? So please do not misunderstand me, because it doesn't need to be an industrial PC. It could also be a server room next to the shop floor, right?
You try to get as close as possible, I guess. And then again, I'm not a specialist in 5G. I mean, 5G, wasn't that the first mobile standard that has been adopted separately or as a special solution for an industrial wireless network as well, right? So the
private 5G networks.
I think companies have been working on that for many years now. So I think that is probably one. And if then within your 5G network, you could have a server or, a small server farm, but that can, of course, also be connected. That can sit next door of your production line if that's what you decide to do.
Exactly.
And that will then probably more typically today be connected by cable, whatever solution that is in the end, right? Yeah, but I'm with you. I think edge has never been exactly been. It was always like it can be a handheld. It's your mobile, it's your smartphone, it's your whatever it is. It's a PLC. It's a machine wherever things happen, right?
Yeah, but what's interesting, it's not a technical discussion anymore, because before SBS, I had a conversation with a machine manufacturer, and their AI developers told me we can't sell AI products if they have a cloud connectivity or a cloud is involved, because the ROI is not feasible for us. It's not feasible. We can't sell it. And that was very interesting. They spoke about a vision topics and they said, please, no cloud connection, please. We want to run our models on the camera, on the edge, next to the shop floor. Yeah.
Of course, we have always had the discussion, as you say, 5, 6, 7 years ago we started with it. And at that time, it was more, we talked about the crown jewels and how European number one, German providers, German companies, people, us within our companies were, more afraid of others or more careful. Let's say more careful than others of protecting our crown jewels and not putting them somewhere too far away.
But this is the topic because of money.
Yeah, I was going to say that was at that time. And I think that has changed. And it doesn't mean at all that if in the meantime we had, interviews with colleagues from the United States or India or from wherever, we would also hear the same story every now and then. It doesn't mean that people over there and you listeners from those countries are not careful. And I was going to say that was 5, 6, 7 years ago. And that today, I think it's a different kind of topic, but it's still, you wanna have the inference as close as possible to where the rubber hits the road, where production is actually being done. That's for me a very logical thing to expect. Yeah.
Absolutely. Pierre, what do you have?
Well, I was going to ask you one thing because there was an announcement actually a couple of days before by NXAI. Maybe you can just comment. There was an announcement on Tyrex running on a PLC, right? There you go. And it was mentioned, the edge. And then there was a rumor, but the rumor was not confirmed, which was that Tyrex 2 was coming. And I asked people that were going to go to the SBS to confirm the rumor. I haven't seen the confirmation. Can you confirm that?
It's a rumor, but I think it's you will see something in, I think, February, March, where the guys are working on covariants and multivariants, and it looks very promising.
Looking forward to. I saw a post by Colin Masson. Well, he was reproducing the post, commenting by Highbyte. And Highbyte, I don't know Highbyte, but I think I want to get to know them because they released a new MCP. There it is again. We didn't talk MCP for at least a month. But they have services, MCP services for industrial AI. So they're what they call Intelligence Hub version 4.3 introduces an MCP client connection that allows industrial enterprises to localize, consolidate, control access to a third-party MCP servers. Now, what is very interesting for me, and that's why I would like to talk to someone from Highbyte who is knowledgeable on the topic. Their solution also includes new out-of-the-box MCP server tools for popular connections like MQTT and OPC-UA, which you and I know very well, and we run the OPC Foundation podcast, that are ideal, they say, for companies getting started with agentic AI use cases like asset maintenance, quality inspection. So that was the question that I've been asking probably half a year ago, when MCP was coming to the market and everybody was producing servers. And I think then we've had for a couple of months this joke that we had a 1,000 servers, but there was only one client requesting the services. You saw those wonderful, what are they? Cartoons, I guess, right? Everybody producing cartoons these days, right? Oh, I saw one from the Siemens CEO. He produced his own cartoon. Did you see that one? Because people were asking him how fit He was, and he was showing what he was doing in daytime was very. But that's a completely different topic. Yeah, if there's one of you Highbite listening, if not, I'm going to get in contact with you. I'm very much looking forward to exactly the combination of those two. What does it mean to? My interest is, or our interest is, because of running the OPC way. But at the same time, if they say MQTT, where do those protocol or communication architecture sit in combination with the MCP server? Maybe I can do a interview end of this year, if not beginning next year. I hope I can share with you what it is that they exactly deliver to the market.
And MCP, our friends from MassWorks, also contacted us because they also showed something when it comes to MCP and agentic frameworks.
I saw that.
Yeah, at the SPS. I visit Norbert. Greetings to Norbert. And yeah, very impressive, interesting approach. Engineering with MassWorks and MCP server. Yeah, interesting.
Right, I saw that. And they were announcing a webinar, I believe. And that's where I saw that they were going to include an MCP server as well. Now, I typically, when I click on a button to attend one of these, doesn't matter where, I typically do not find the time in daytime, but I always love to get a link with the recorded version, which makes me always a little bit more flexible getting towards the stuff that I need to know myself.
I will share the link. It's called Agentic AI Workflows with MATLAB MCP Servers.
Perfect. Thank you for that. A little bit of history here. Jürgen Schmidhuber, he asks, why did deep learning originate in Ukraine, which was at that time USSR? We're not going to get into any details of things happening these days. 1965, he says, at that time, the USSR was leading many important fields of science and technology, most notably in space. I'm not going to list all, but 2-3 of them. First satellite, 57. First man-made object, first man in space, 61. First woman in space. And there's many, many more. And he says Ukraine was home to many leading mathematicians with sufficient funding for blue sky math research with enormous significance would only emerge a couple of decades later, which is happening today. So I, in all modesty, came up with a second version of the bitter lesson. So I suggested the bitter lesson. We all know, and we still hear it everywhere. And when you in the beginning, we didn't finish that. Not my thought. When you said, yeah, there's still partly a lot of hardware with the drives and other folks at SBS. But the bitter lesson that Richard Sutton, he's the driver of reinforcement learning, right? Probably the inventor, 2019. He says CPU outperforms intelligence. Bitter lesson because he says as much as like, well, you can be as smart as you want, do whatever you want. In the end, CPU is winning. Now, that is not necessarily still the case. I think we take NXAI as an example, XLSTM, which I call then human intelligence. Do things smarter than before. Take the relative, 27 years ago LSTM, and then the human brain comes with a better solution. Anyway, I came up with a bitter lesson 2, 2025, Peter Seberg, and I said marketing budgets outperform bitter lesson number 1. I'm not going to go into further details here, but yeah, we do need to be careful. And every now and then, when that's what Jürgen typically does, when he confirms his perspective. When I say his perspective, he's always looking for the truth. And when he shares what has happened and where the things that we do today, where they have come from, I think it's a useful thing to know.
And he visited relatives of the scientist together with Jan Kutnik, I think.
That's what you heard from Jan, right? Because Jan at that time working.
Yep.
You had Jan over. Yeah, I heard that. Yeah. You had Jan over actually 1 week ago. He was...
Yeah, 2 weeks ago.
You guys were drinking tea and preparing for Christmas and
Punch.
Talking about AI in industrial. Or?
Yeah. We have an event format in Linz called KI Punch, AI Punch. and you drink a little bit of alcohol, and then you talk about AI.
So that's so European. I hear all my American friends. Oh, those Europeans, they drink alcohol and work, and then okay, sounds good. Yeah, and what we call punch.
Exactly.
Is that probably, maybe it's not the English word? I guess the punch is more like a punch in the face, like a slap.
No, it's not punch. It's called punch. What is it?
When we say a hot wine,
it's a wine, a sweet hot wine, I would call it. Yeah.
But there is always what we call a child version of it as well, right?
Child version,
which does
exactly.
not have alcohol in it. So we do
with a lot of sugar.
We do not always drink alcohol during work.
But I want to come back to Richard Sutton and the scaling topic, right? Because Ilya gave an interview, what Sepp said last year at NeurIPS, that scaling is over. And Ilya said the same in the interview, that scaling is over. We need to find new ways to do AI. So that was very interesting. 1 year later, Ilya is also convinced. Yeah.
And I didn't know that. And the example I gave with the human intelligence, very nicely, my brain immediately brought me to Sepp, because he is one of course, many others as well, very well deserved people that, has used his brain to help us further in what we do with artificial intelligence these days. Now, as you were saying that again, and as we started today with the edge and the cloud, and nevertheless, I mean, big tech is building hardware cloud like crazy, as crazy as. Now, nevertheless, maybe it still means that as we used 5, 6, 7 years ago, we said I think at that time we said, what was it? Was it already at that time 80% cloud and 20 edge? And we said it's going to go the other way around. If we look at transaction cycles, let's say CPU cycles, right? It could still be. So even though if we then now build 1,000, let's say PLCs or pieces of server, small farms close to the production line, if there's 100, that could still mean that we're going to have like 20 somewhere as a cloud. I have no idea. But if you listen around, and even again, I hear, Germany is getting out of nuclear technology, that seems to be really weird these days, because in other parts of the world, like Google, they're rebuilding, nuclear power plants, which have been put down to be dismantled. They say, no, let's stop, let's use them. There seems to be some kind, I'm not sure if it's a disconnect or what is happening there.
But you need cloud infrastructure for training, right? So there is a market for cloud infrastructure and for cloud training. And absolutely, I'm not saying that we do not need cloud, but for inference topics running on the shop floor, there's no option for that. But there are a lot of more use cases out there you can run easily on a cloud, and the people will pay for that, and they are happy to do that. And training for sure is a crucial topic when it comes to cloud infrastructure. So for training, absolutely, you need that. Yeah.
Yeah, completely with you. And the thought that comes to me is like, I actually believe that I can't find the number, because whatever, we're not talking trillions, zetas, petas, whatever the number is these days, I have no clue. And the number is so huge that my feeling is it's not meant to be used, also not in consumer inference. So if I say consumer inference, when I use something on my phone, which is not yet edge, and it will have an edge solution in the future as well. But I think today, as Peter Gostev, I come to Peter in a moment, he said, sure, when you're using a Pixel, as I do in my case, as soon as the Gemini 3 is going to be available, that's what you will be using, because you are going to have this connection to the cloud. Now, the point, nevertheless, is that may be the case. That's why they are building this huge cloud infrastructure. My belief is that any of the 4 big tech, and then adding, the Chinese and some others, maybe there's 5 or 6, that they believe that the one that is the first going to have the ultimate kind of quality large language model, which they still believe, But Ilya said, no, that's not going to happen again. But I'm still thinking, as you can hear, why they're building so much. And maybe I believe it is for that reason, that they think that if they're going to put 1000x capacity CPU up there, then they're going to come with the best ever, up until the point where they say, okay, now I'm the best, and all the other ones have lost. That's a little bit my feeling.
But at the end, our industry, industrial AI, is a niche for them, right?
Yeah. And,
it's a niche. It's an absolutely niche for them, right?
Peter, I just mentioned Peter Gostev. He says the success of Google's recent AI launch, I just mentioned it, Gemini 3, I run it on my local phone. It shows that the focus on the problem,
it's very impressive,
and not the solution mantra in products, is basically BS. That stands for bullshit, by the way, when you have a new big tech wave. Okay, I'm not going to go into the details there, but my 5 cents, and they are related to Jürgen's, and you can make the connection yourself. I said the success of Google's recent AI launches, they have a Nobel Prize winner with them, right? Demis Hassab is not this year, last year, I believe, right? He was did he get the Nobel Prize for, I'm not sure what.
In chemical Nobel Prize, I think.
Yeah, right. So this for his work on AlphaFold with the protein stuff, right?
Yeah, but it's interesting because Dennis hired now the former CTO of Boston Dynamics, and Boston Dynamics is a robotics company and based for sure in Boston, and maybe the robot dog and stuff like that. And now there are some rumors is Google DeepMind going into robotics now? Yeah, let's see.
But they had
they had some experience with robots. Intrinsic, yeah. But it's a niche, right? It's industrial, so it's a niche again. It's the niche, and maybe they are now going into another direction. But let's see. So, Peter,
good. I think I've got a final piece here before you can tell us what you're going to be doing at Europe's this week. I saw Philip Leube. He's a product owner, R&D manager at Trumpf Machine Tools. And he asked if you are passionate about machine learning on real machines, or if you want to implement the latest AI methods, RAG, agentic AI, or analyze, optimize newly launched AI products, apply for one of their internships. So we're going to share the link with you if that may be of interest for you.
Perfect. So yes, you already mentioned I'm on my way to Copenhagen for the first European Europes, and that's they've split up. Some are flying to San Diego, but a lot of Europeans are going to Copenhagen.
Right, it's in parallel, the same week.
It's in parallel, yeah, this week, and it's organized by the Danish guys, and a lot of Nordic AI professors are involved in the whole organization. And I think it looks very promising. It's sold out, so you are not able to buy any tickets anymore. I will check it now this week, and I think we will see a Europe's next year again. I'm pretty sure.
Okay, and it's going. Okay, we don't know yet, but it doesn't necessarily going to stay there, or is it going to be in Linz next year or Munich? Or
no, it's normally it's next. Like the big Europes last year was in Vancouver. This year is in San Diego and Mexico City. Mexico City is also this year a host of an Europe's conference. It's a political topic, right? Because of travel restrictions, exactly.
Because of things happening. Right. By the time that you hear this, dear listener, Robert will have been at Europe's already for a couple of days. So we're going to get a complete feedback from you the next time. The next time is actually the last time that you and I talked. We do the news section for this year. But I'm looking forward to hear from you. Wish you a wonderful time. I know that Christian Gilch is going to be there, Embraceable AI, maybe not himself, but his company. I heard from a couple of other companies. I'm very much looking forward to hearing from you how that's going to work out.
I'm really looking forward. There are a lot of interesting people coming from the Netherlands, and as we mentioned, Nordic, because in the main part the main part takes us to Iceland today. And the guys from Treble Technologies will also come to Copenhagen, and the CEO studied in Copenhagen. So we're closing the circle. And the main part is all about sound, simulation, and ears for robots. So very interesting company. I met them in Berlin in summer, and then I came back to them 2 weeks ago, and because we had a discussion about sound and time series, etc. And it's a very interesting approach, very interesting company, very interesting topic, and I think it's a niche, but maybe it's a very interesting niche. Yeah.
I saw that Audeering. Do you recall Audeering?
Yeah.
I think I tried to get them on, but I think I never managed. And they were bought now by the Munich robotic company, which I assume you know. If you don't know, that's okay as well. And the thing I was going to say on this topic is they were bought just, and I think that's a logical thing, to enable a robot to hear, right? So far we've been concentrating on, it's making how many do we have? 5, 6, 7 senses available to the robot, right? So we've been concentrating on vision, on making the robot capable of looking. And now we're going to make sure that they can listen to us as well.
And it's very important that they are able to listen, because when we talk about humanoid robotics, imagine they are going through the factory and in the back there's coming a car or there's coming something, and they do the horn, and now they need to know, is it in my back or is it 300 meters in front of me? Yeah.
Good. Robert, have a wonderful time in Copenhagen.
Thank you. Bye-bye.
Talk to you soon. Bye-bye.
Today I'm sending my regards to Reykjavik. My guest is Dr. Finnur Pind. Finnur, welcome to the podcast.
Thank you so much, Robert, for having me. Great to be here.
We will talk about high frequencies today, so-called treble, and the company's name is also Treble. I think there's a connection between both topics. But before we start, please introduce your company, Treble Technologies, and explain what are you guys doing.
Yeah, thanks for that. So we are a simulation and synthetic data generation platform, specifically focusing on sound. So being able to simulate how something is going to sound.
So it's high frequencies, right?
Well, I would say it's a broad range of frequencies, from low to high, indeed. And yeah, the two main use cases we serve. On the one hand, we could call it virtual prototyping. That's like the classic use case for simulations, being able to virtually test how something is going to work, and in this case, how something is going to sound. And then the other side is synthetic data, being able to run a lot of simulations to then generate large data sets to train and test some kind of AI model working with sound. So that's what we do.
Who needs sound data?
That's the beauty of working in the world of sound, is that sound is everywhere. It touches so many different industries and use cases and products and so on, which makes it a very fun, career choice, I guess. And, for us, indeed, perhaps, voice technologies, all kinds of consumer electronics devices that work with sound in some sense, automotive industry and so on are sort of maybe where we started, let's say, and we have a lot of traction in those industries. But then also...
So automotive means in the car, right? For the radio or for the entertainment system.
Yeah, exactly. And voice control as well and so on. So this is kind of where we started, and great traction on these, perhaps especially in the kind of consumer electronics and voice space. But then, indeed, sort of emerging use cases as well. For example, robotics is very interesting, where robots will, I believe, certainly leverage sound in the future, just like we humans do for situational awareness and communication and so on.
Can you please explain a little bit the technique behind, because you only, in quotation marks, offer the sound data, right? Or am I wrong?
No, exactly. So our customers are typically the ones who are developing the AI models themselves that process the sound, and we allow them to generate very high quality data, which is a very big part of AI development in general, the data side of it. So that's kind of the line in the sand we draw between us and our customers.
Maybe I'm not a professional guy when it comes to sound, but you can record sound everywhere, right? Why do you need synthetic data of sound?
That's a great question, and indeed, that's what companies have been doing up until now. And it's certainly one way of doing things, and nothing wrong with that per se. But what the two main challenges with that, on the one hand, it's just not very scalable. It's very time consuming and expensive to go out in the real world and collect data. So that limits the kind of scale of the data sets people can work with for training and testing. On the other hand, it's also it's hard to obtain, let's call it clean data, reproducible data with all the right metadata associated with it and so on from the real world. If you go to a restaurant and record sound in there, how can you separate out the different sounds that are in the restaurant? Where can you label where all the sound sources were and so on and so forth? But that becomes very straight, in quotation marks also, very straightforward to do in simulation.
Mm-hmm. Who had the idea to do that? And how came this idea reality? Can you go a little bit back in history of your company?
Definitely. So the roots of the company go back to academic research that was going on for some years, including my own PhD studies at DTU in Copenhagen.
Denmark, they are doing a lot when it comes to sound, I think. Yeah.
Exactly. You could almost call them like the audio capital of the world.
Yeah, absolutely. Yeah.
A lot of history there, and the loudspeaker was invented in Denmark.
Exactly.
But anyway, we were developing technologies to simulate sound and acoustics and wave propagation, with more precision and more efficiency, so faster and more accurate than what had been previously possible. And to be honest, we were not so much thinking about synthetic data generation or AI even. We were thinking about virtual prototyping, and we were thinking about building design, for example, developing technologies to help architects and engineers design buildings with better acoustics and less noise and so on. And by the way, that's a industry we do serve here at Treble. So when we started the company, this is 2020, that's sort of a spin-off out of this academic research. We had, in the academic research, really built a very promising prototype of this simulation technology, something that could simulate very fast, very accurately. And then Treble was founded as a spin-off out of that. And we decided actually to start focusing on the building industry. But we knew also from day one that, being able to simulate sound very accurately and efficiently, that we know that has use cases, in several industries. So we want to do more than just buildings with time. And then we got going, and we were, active on LinkedIn, telling the world about our great tech and going to some conferences and so on. And then we started getting a lot of inbound requests like, "Oh, I heard you can simulate sound very accurately. Can you do that at scale so I can simulate, 10,000 environments in one go?" And we were like, yes, of course.
Of course we can do that. Give me 4 weeks.
Exactly. And then we scrambled and built more of an SDK offering rather than like a simulation software, a GUI software for the purpose of running simulations at scale to generate data. And that's kind of how we transitioned into this space, which has now become our main line of business, really.
From my understanding, sound or sound files, as we record here today, are time series, or am I wrong?
No, that's correct.
So do you process your data or your files or your sound files as time series? Or can you explain a bit, how do you process your data?
Yeah, exactly. I mean, it's time series, often multi-channel time series.
Multivariant, okay.
Yeah, to encode some spatial information as well.
Okay.
And what we simulate at the end of the day is you have a 3D environment where there's geometry, there's materials, there's sound sources, there's listeners, and we simulate the sound propagation from a source to a listener in a 3D environment, which is a time series signal, really, which is the output of the simulation, and then you can use that for your AI development.
What do you do with these time series when you build your data files? How do you process these kind of? Do you do forecasting or classification tasks also? Can you explain a bit?
Yeah, absolutely. There's a broad range of use cases, AI and ML use cases. I can give a couple of examples. The topic of speech and speech processing, voice.
Speak recognition? Yeah, okay.
Yeah, exactly. That's a major area, of course. And there maybe you're developing a model that is supposed to pick up speech very accurately and feed into speech recognition and remove noise and reverberation and those kinds of things. And then you would, for example, feed into that kind of a system like the clean speech and then the distorted or unclean, reverberated
As a noise, yeah.
speech. Exactly. And from realistic scenarios, so not just some arbitrarily distorted speech, but the way it would be in real life. And then you feed those two into kind of a supervised learning paradigm where you teach the algorithm how to remove all the noise and reverb and clean up the speech. That's a very classic example of a audio task. Another one is maybe more related to sort of spatial awareness and so on, where we have multi-channel audio data, and we also have spatial information and metadata, and then we can again feed that into some kind of, for example, source localization task, where the goal is to figure out where exactly a sound is coming from, and you can have multiple sounds at the same time and coming from different positions, different things moving around in the scene and so on. And then you maybe detecting, it could be anything. It could be a person walking around. It could be a drone and so on. So these are at least two examples.
What is so difficult when it comes to sound data, sound files, and synthetic data then?
One can do some things with simple methods, let's say, and that's what's been done in the past, and that's certainly better than nothing. But when you want high level of physical accuracy, which is needed in at least many applications, then you need to capture the physics of sound well, and in the physics of acoustic propagation in 3D environments, and then it becomes pretty complex, even though the main physics equations were discovered, I don't know, 200-300 years ago. Then still being able to accurately model that in a variety of environments with accurate precision. Yes, there are just so many variables at play, so many things that can influence. Imagine you want to replicate, again, maybe a restaurant example with all the different materials, all the different types of sounds, all the different types of sound sources. And you want to model this all so precisely that you can exactly replicate what an AR glasses headset would perceive in one particular location, and the phase difference between the two closely spaced microphones on those AR glasses, etc., etc. So it becomes quite
challenging.
Yeah, exactly. But a fun challenge.
Yeah, I want to come back to your customers. How do you work together with your customers? Can you explain a bit the relation, or is it really a scaled platform where they can download the files or the data sets? Can you explain a bit that?
Yeah, exactly. Some of our customers include the big tech giants, consumer electronics companies, and so on. And what they do is they actually operate the tool themselves, in the sense that we're not just like a data vendor or data set vendor. We actually give them tools so that they can really go in detail and tailor their data sets and create data sets in certain ways. And then it's an iterative process. Of course, they train a model, they see some results, they see something works, something needs improvement, some scenarios work, others not. Then they go back to the data set, generation, tweak things around, train again, and then it kind of goes on like this. So that's a typical relationship.
Today, everybody is talking about language, or not language, maybe text. Do we underestimate sound in the certain status of AI?
Yeah, that's a good question. I mean, text is very powerful. Don't get me wrong, but yeah, I sort of feel like the next, there's going to be exciting developments over the coming years, going beyond just text and into kind of to spatial applications, into physical AI or whatever we should call it. Voice is going to be a very good interface to AI.
Voice and time series.
Yeah.
So at the end, it's a time series topic. Because I did an episode with Jakub Tomczak. He's from the Chan Zuckerberg Foundation in US. And he told me that time series, and sound is also a time series, is a new frontier in AI. So we solved the text topic. Now the next thing to go further in AI are time series and then also sound.
Right. Exactly. That's a very exciting thought. Yeah.
What is your goal of your company? What do you want to do in the next coming 12 or 24 months? What is to improve your approach, or are you looking into models maybe, or do you say, oh, models, we are not interested in models, do your model stuff? So what is your approach for the next 12, 24 months?
Right. That's a great question. Maybe I answer it kind of in a twofold way. First, I would say sort of the grand vision is, that Treble rests on this hypothesis that sound is a very important component of daily life, of AI in the future, and of physical AI and so on. And that being able to simulate sound and generate synthetic sound data is going to be and continues to be very, very valuable. That's kind of the hypothesis or fundament we rest on. And we are working to realize that. And over the next, our core offering is very powerful by now. And we have great traction in certain industries. So really what, we are focusing on is kind of not just scaling up, but also scaling out, if you will, or sort of horizontal scaling to new use cases. So I think that's very exciting.
So you mentioned robotics, right? And I think your COO wrote a very interesting article about robots and the ears of robots. So ears of the robot, is that a horizontal scale? Is that the idea?
We are at least very excited about that space and definitely believe, and have some evidence on that robots can benefit from using sound. I would say two main dimensions to that. On the one hand, it's situational awareness, spatial awareness, and so on. On the other hand, it's the communication component between humans and robots, where we see, and I don't think that's a coincidence that nature evolved humans in such a way that we heavily rely on sound, because it's just a very powerful medium and a convenient way to sense the world and communicate with the world. And therefore, I think it's also reasonable to assume that the same will apply for robots.
Let's talk about, in the end, a little bit about Reykjavik and AI. So you studied in Denmark, and you came back then to Iceland and Reykjavik. What is so special when it comes to Reykjavik and Iceland when it comes to AI?
Yeah, that's a good question. I mean, it's a hot topic like everywhere else. There is a powerful startup scene in Reykjavik.
Really? Okay.
I would argue that it punches above its weight, if you know what I mean. There's a good ecosystem. There's good support for startups getting going and so on.
You have a lot of energy, right?
And that, exactly. So data centers, that's a very major topic in Iceland, and not just in the startup scene, but generally speaking in the in the political climate and so on. Because we have a lot of energy, a lot of green energy. So that's attractive for powering data centers.
Yeah, absolutely. Do you run, you don't need so much GPUs for your approach, right? So it's a moderate approach. Or am I wrong?
I would say we actually need quite a bit. Of course, it's all relative, we use less than some, but it's pretty heavy computations we're doing.
I want to come back to your market. Is there any competitor in the market, or can you share a bit about the market? Who is doing something what is nearly to your approach, or are you really the one and only on the world to do that?
Right. I would say there's no direct competitor, but there are some, adjacents or indirects or some parallels to some others. Certainly, there are many companies working in the world of synthetic data generation and, for physical 3D environments, physics and things like that, but not exactly sound. But we take inspiration from those kinds of companies as well, and it's also very exciting to see, for example, NVIDIA really doubling down on developing platform for physics synthetic data generation. That's very cool. But they don't do sound yet. Yeah, then there are some more kind of classic simulation software that have some modeling capabilities for sound, but that's much more focused on this virtual prototyping use case and not data.
So it sounds very promising and a very promising technology approach from Iceland. Finnur, what is in your agenda for the next 3 to 4 weeks? What do you have to do? Do you visit Europe in Copenhagen because it's your home turf, right?
Right, exactly. Unfortunately, I won't go there. I've been traveling extensively over.
You have been to Slush?
I went to Slush. That was amazing. Yeah, exactly. And what's on the agenda for me, it's a lot of great conversations with our customers and also kind of prospects, people who are excited about our offering. So I'm spending quite a bit of my time talking to companies who are interested, and that's always a lot of fun to kind of hear their challenges and try to work with them on finding solutions and so on. Yeah, and then we're kind of scaling up as well, so that's exciting.
And you're looking for new guys to join, or?
Exactly. So that's also a very fun topic to think about.
Okay. What you're looking for? Machine learning guys or data scientists? What profession are you looking for?
Yeah, for example, exactly. Even though we're not, at least not yet, developing models per se, and we still need very strong machine learning talent to.
But is it an option to develop models?
It is an option. Yes.
Okay.
Yeah, something to be mindful of.
Okay. Finnur, it was a pleasure. Thank you very much that you talked about your vision, your approach from Treble Technologies. All the best and greetings to Iceland.
Thank you so much, Robert. It was a pleasure. And thanks for the very nice questions and discussions.